Welcome back, my fellow programmers. Today on the program, we'll be covering lesson 5.2, constructors. Now, we've seen constructors before, we've called constructors before. We are going to take a closer look at what goes into a constructor. So let's start the program. Our first lesson is just called Constructor. Our learning objective: designate private visibility of instance variables to encapsulate the attributes of an object. Imagine for a moment that you are a short order cook at a restaurant that sells only omelets. On the menu are just two different menu options. You can get the default omelet, which is just 2 eggs and cheese, or you can build your own omelet in which you select the number of eggs and the fillings that you want to go inside that omelet. As the short order cook, you are going to be getting tickets that say what the customers want to order. Sometimes the customer will just order the default and you'll know how to make that. And sometimes they will specify how they want that omelet to be made. And it is your job as the cook to make that omelet in the way that they want it. That is sort of similar to the job of a constructor in our class. Its job, it just has one thing it needs to do. It just needs to build the object according to the user's settings. You can think of this like a construction worker. If you are a construction worker, you will usually have one very specific task that you work on. You might be the roofer, and it is your job to peel off the old roof and put on the new roof, or you might be a bricklayer, and then your job would be to then put the bricks together to build whatever structure you are building. Let's take a look at how this looks in the computer. We have a toaster class. We can see two lines of code where we are declaring and instantiating toaster objects. On the left, we have a toaster object called T1, and we are assigning it to the address returned when we call the toaster constructor. On the right, we have something similar, but we are making an object called T2. When we call these constructors, each time they will construct a toaster for us. Now, those toasters each have their own member variables, and those member variables will be set to unique values. We refer to that as the state of the object. In this case, both of the states will be the same because the constructor, those toasters were constructed the same way. The member variable color will be set to silver. The member variable slots will be assigned the value of 2, and the member variable of heat will be assigned the value of 0. And that would be for both of them because the constructor constructs those the same way. Now then, if we called a setter method or a mutator method on object T1 and we set the heat to 3, and we called a different setter method on object T2 and we set the color to blue, well then the state of those two objects will change. Toaster T1, the heat setting will move up to 3. Toaster T2, the color will change to blue. And then both of those objects will have different states. They still have the same three variables, color, slots, and heat, but those variables can take their own unique values. Therefore, the relationship between the variables and the object, we say the object has a color. For T1, that color is silver. And the object also has a heat. In T1, that value is 3. This aligns with our essential knowledge. An object's state refers to its attributes and their values at a given time and is defined by instance variables belonging to the object. This creates a has-a relationship between the object and its variables. Let's imagine for a moment you work in a factory that makes toasters. Every day you get a list of special order toasters. Each special order will specify 3 attributes: the color, the number of slots, and the heat setting. Throughout the day, you will get different order slips, and then based on the attributes specified, you will have to create those toasters. So you might get one order that wants a silver toaster with 2 slots with the heat setting set to 0, and you might get an order that wants a red toaster with 4 slots with the heat setting set to 0. What that might look like in code, we would have a file called toaster.java. Inside of that file, we will have our class definition. On line 1. We see we have public class toaster. We are giving it that access modifier of public. That means that we can see this class from other files like main.java or any other file that we make. We have our member variables. They are given the access modifier of private for encapsulation to protect that data. We have a member variable for color, a member variable for slots, and a member variable for heat. In order to create these toasters, we would need a constructor that would accept what color the customer wants and the number of slots that the customer wants and the heat setting that the customer wants. It would accept these values and then it would assign them to the member variables. This aligns with our essential knowledge. Constructors are used to set the initial state of an object, which should include initial values for all instance variables. Now, we've been programming long enough that we know that we don't actually get an order form. What we would have is we would have a object declaration and instantiation statement in which we declare a toaster object and give it a name. We would assign it what is returned by the constructor after we pass in these 3 values. When we use that constructor and give it the string literal of silver, that silver will go into the toaster class, into the constructor, and we are just going to refer to it as customer color. We then take that customer color and then assign that to the member variable color, which is the same member variable that was defined on line 3. If we look in that constructor and see customer color, customer slots, and customer heat, if we are looking at those variables have what's known as local scope. They only exist inside the constructor. They were declared as parameters of the constructor, and then they will only stay in memory until the closing curly of that constructor. They have a very short lifespan in memory. What we need to do is we need to take those values and store them somewhere where they can be, where we can reference those values later. That's why we take those values and we put them in the member variables. The member variables live longer in computer memory. We should not reference these variables, customer color, customer slots, and customer heat, again after the constructor is done. This aligns with our essential knowledge. Constructor parameters are local variables to the constructor and provide data to initialize instance variables. Our next lesson deals with passing objects. Our learning objective: designate private visibility of instance variables to encapsulate the attributes of an object. Here's a picture of a pond. I thought we would like to see a pond. Just picture ourselves just sitting on the dock and just relaxing. I know all this computer science stuff can be a little bit complicated. And you're just sitting on the pond, on the dock, staring at the pond, and you see a duck in the pond. You might see a yellow duck in the pond. You might see a blue duck in the pond. You might even see a pink duck in that pond. And that gets you thinking about duck objects and pond objects because you just can't get your mind off of computer science. Well, if we have a pond class, we might have member variables, and those member variables might be objects. We might have a duck object, and we might have 2 duck objects. We might have 3 duck objects. We can have up to 3 ducks in our pond. That pond class will have a constructor in which we will accept 3 duck objects from the user, and then we will assign those duck objects to our member variables. The duck class might look something similar to this. A duck might have a name that's a string, and an age that's an int. Therefore, our main.java might look something like this. We could declare and instantiate three different ducks. M1 would be a new duck named Howard with an age of 50. M2, new duck Daffy with an age of 86. And M3 would be a new duck Donald, who is the oldest duck at an age of 89. And then we would take those three duck objects, M1, M2, and M3, and we would pass them to the pond constructor. So then they can then be the three ducks in our pond. How this looks in computer memory on line 3 of our main class and our main method, we have duck M1 is equal to new duck. We pass in Howard and 50. In stack memory, the variable M1 gets stored in there. That's the variable that we are creating in main to hold our first duck. That's why we're calling it M1, because it's in the main class and it's our first duck. Now the duck has its own variables to remember, name and age. Those go in heap memory. They would go in the first place in heap memory, which would be H1 and H2. We have name, which is assigned Howard, and age, which is assigned 50. Now, the variable M1 from our main class gets the value of, we know that we have a duck at heap 1. We go to heap 1, and that's where we find our duck. Line 4, we are making duck M2. In stack memory, we make that variable M2. In heap memory, that's where we put the object's variable values that defines its state. And M2 has a reference to duck at H3. And then finally on line 5, we make duck M3. We put its instance variables in heap memory, and M3 again is a reference to where we find it, duck at H5. So M1, M2, and M3, remember those are what we call reference variables. They hold the address of where to find the duck. They don't actually hold any of the duck's values. They just know where to go to find the duck values. We call those reference variables. So M1, M2, and M3 in our main method are all reference variables. On line 7, we are creating a new pond, and we are going to pass those three reference variables, M1, M2, and M3, to the pond constructor. We are going to follow the path of just the reference variable M1. M1 is that reference duck at H1. We can see that in our stack memory. That goes into the first parameter of the pond constructor. We're going to call that D1. D1 then gets assigned to the instance variable of P1, and so that's the P1 that is our member variable. In our heap memory, we are going to get P1. P1 is going to hold a reference to the duck at H1. When we look at our stack memory, M1 and P1, they both hold a reference to the same duck. So the one in our main class and the one in our pond class are both pointing to Howard, who is 50 years old. They are what we call aliases. If somebody changes the duck value in the main class, if anyone changes M1, it will be reflected when we look at it in the pond for P1. And same thing, if we change it in the pond, it will be changed in the main. You usually do not want to make aliases of your objects. It becomes difficult when two things point to the same object, keeping track of which one you want to actually reference and be able to change the original duck. So the pond constructor is going to get a duck reference. We don't want to just assign the member variable that duck reference. What we want to do instead is we want to create a new duck using a copy of the values of the duck that was sent to us. That means we should call the getter methods for those instance variables of the duck and just create a brand new duck that has the same name and the same age. And that way, the duck in the main class is different than the duck in the pond. This aligns with our essential knowledge. When a mutable object is a constructor parameter, the instance variable should be initialized with a copy of the referenced object. In this way, the instance variable is not an alias of the original object, and the methods are prevented from modifying the state of the original object. Our next topic is the no constructor. Our learning objective: designate private visibility of instance variables to encapsulate the attributes of an object. So sometimes it's your job to make a toaster and you ask the person, what kind of color would you like? How many slots do you want? And what heat setting would you like? And they don't care. They just want a regular old default toaster. And it's just your job to get them that default toaster. Let's take a look in our main.java on line 3. We are declaring and instantiating a toaster object named order001, and we are assigning it what is returned when we call the toaster constructor with no parameters. So we are not specifying any of those initial values. We are not specifying that initial state. On the bottom, we have our toaster class, in which we have our class definition on line 1. We have 3 member variables starting on line 3, but we don't have a constructor. What would happen if we tried to construct a toaster, but we never defined a constructor in our class? We know that we want to make a toaster object. We know we want the name of it to be order001, but what would be the initial state of those member variables? The job of the constructor is to initialize those variables to their starting state. If for some reason you do not provide your class with a constructor, Java will provide a no argument constructor, and that no argument constructor will initialize the member variables to their default values. Since string is an object, its default value would be null, meaning that there is no reference in that memory location. Slots is an int, its default value would be 0, and heat is also an int, so that default value would also be 0. This aligns with our essential knowledge. When no constructor is written, Java provides a no argument constructor and the instance variables are set to default values. Here's a more formal definition of that no argument constructor: a constructor that does not accept input and sets instance variables to default values. We should review the default values of those primitive data types. We just previously saw that for an int, the default value is 0. For a double, the default value is 0.0d. For a Boolean, the default value is false. And for that primitive data type of an object reference, the default value is null, meaning that it does not hold an address because there is no object to point to in heap memory. Looking at the code in the box on the left, we have a definition of a duck class on the top, and in the bottom of the box, we have the definition of our main class. In our main class on line 3, you can see that we are declaring and instantiating a duck object, and we are calling the duck constructor. Looking inside the duck class, we do not see a duck constructor. We never coded a duck constructor. So Java will provide that no argument constructor for us. And the job of that no argument constructor is to initialize the instance variables to their default values. So the state of that duck object M1, name would be null and age would be 0. Looking at the code in the box on the right, at the top, we have a definition of a pond class. At the bottom, we have our definition of our main class. In the main class, we are declaring and instantiating a pond object named pond, and we are assigning it the reference returned by calling the pond constructor with no arguments. If we look in the definition of our pond class at the top of the box, we can see that we never coded a constructor that accepts no arguments. Hopefully by this point, you are yelling at the screen that Java will add that no argument constructor into our class if we never put a constructor in there. And that the job of that no argument constructor is to initialize the instance variables to their initial values. Since these are all objects, the initial state of object pond, P1 would be null, P2 would be null, and P3 would also be null. In this example, on line 3 of the main.java, we are still calling the toaster constructor. We're making a new toaster called Toastmaster, and we are calling the no parameter constructor. If we look down in the toaster class, we do not have a constructor in here. We know that Java will automatically provide us the no parameter constructor. The question is, what is the state of this object going to be if on lines 3 through 5, we have values for those three variables? Would it still set color to null and slots to 0 and heats to 0? Or would it use these provided default values on lines 3 through 5? Well, if you have default values provided, it will use those default values. By calling the no parameter constructor, color would be silver, slots would be 2, and heat would be 0. This aligns with our essential knowledge. When no constructor is written, Java provides a no argument constructor and the instance variables are set to default values. Here's another toaster that we're making called Toasty. We're calling that no parameter constructor. In this case, we know Java does add that no parameter constructor for us. We have on line 3, color does not have a default value provided by us when we wrote the class. Slots and heat do. What would that initial state of that toaster be? Well, if we don't provide a default value, color will be null, and then it will use the provided default values of 2 for slots and 0 for heat. Here we have an example where we do provide a toaster constructor in which we do want to have 3 parameters, a string, an int, and an int. On line 3, we are trying to call the no parameter constructor. So we do not have a constructor that looks like this down in the toaster class. Is that still going to be okay? Will Java still give us the no parameter constructor to call? Well, no, this no longer works. Java will not give us the no parameter constructor if we have a constructor. Java only provides the no argument constructor if you have no constructors. If you make your own constructor, Java will not give you this one anymore. You can still use it, but you would have to code that in yourself. You would have to add that line that you see on line 13 of the toaster class. You would need to write the line of code for the definition of the no argument constructor. So now this will work again because it does have a constructor defined down in the toaster class. That's going to bring us to the end of our lesson. Make sure you rate how you feel about your learning objective. Read over your recap statements. Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.